At the beginning of this unit, we were talking about cross sections and how you can slice through a shape and get a cross section. So you could slice through a cylinder vertically and get a rectangle, or you can slice through a cone vertically and get a triangle. We're going to take that, and now we're working reverse and start with the cross section. And what happens when we rotate it around an axis? Then what we end up getting is a solid. And so it's called a solid of revolution. A solid, we're revolving it so that we get a solid. Imagine a revolving door going really fast. Or if you have a revolving door and it's kind of enclosed in a room, the shape of that room is a cylinder. Because you take that rectangle that's the door and you rotate it around the axis of the center, and it creates this cylindrical space where the top and the bottom it sweeps out a circle, and the sides sweep out the lateral area sides of the cylinder. So let's look at what these would look like if they were rotated around. So if we were to take this rectangle and rotate it around the x-axis, and just pick a point and you want to rotate it. So we're going to go in a circle. So what you find is that distance is going to be the same. And this is going to rotate the same distance, and you're going to end up with a cylinder. So if you rotate that rectangle around the x-axis, you end up with a cylinder that has a height of b and a radius of h. If you take this triangle and you rotate it around the y-axis, let's take this b and let's rotate it around the y-axis, you're going to get that same b, and then you've got your height. So you have a radius of b and a height of h. Now, if we take that triangle and rotate it around the x-axis, now we have this radius of b and that height of h in that direction. If you rotate, now this one is off the axis, so if we rotate it around the y-axis, it's off the axis. So what we end up having is we've got this other triangle on the other side. So you can imagine the back side of it looks like this, and then the front of it would look like this. So what you end up with is basically a roll of tape, right? Think duct tape. So you end up with a roll of duct tape. And that's what happens when it shifts and it rotates off of the axis. Same thing with this triangle. If we rotate it, so imagine you take this point and you rotate it, and you're going to spin it around. So it's going to spin like that, and then this side's going to spin like that. And what you end up with is kind of this a two-sided funnel, or an hourglass. If you can imagine, that's what it looks like, an hourglass. And then if we rotate this last shape around, let's just pick the points and let's rotate them around. Take our outside points and rotate them around. The points that are on the axis stay where they are. And so we end up with this cylinder basically with a cone-shaped hole in it. Okay, so let's look at then what we can do with this. If we graph these points, we've got 0, 0, 0, 3, 4, 0, and 4, 3. So we have this rectangle, right, that we're going to rotate, and we're going to rotate it around the y-axis. So this is going to be your axis that stays put. Everything on that line is going to stay put. Everything else is going to rotate. And so, but basically if you flip it, just imagine flipping it to the other side, then that's what you create. And now we want to connect those points together, and then it's going to rotate back around. And this one's going to rotate around the back, and then it's going to rotate around the front. And so you end up with this cylinder. You have a radius of 4, and you have a height of 3. And so your volume is the area of the base times the height. And so you get that the area of the base is 16 times 3. It would be 48 pi. Okay, the area of the base times the height gives you the volume of that cylinder. Okay, so let's look at 0, 2. So we have a point at 0, 2, 0, 5, 3, 2, and 3, 5. And we want to rotate it around the x-axis. So then we've got that same thing, flip it over, reflect it across that line. These are going to be our two solid pieces, and we're going to rotate it around the x-axis. And so we're going to flip these around like this, and like this to finish it off. So what you end up with is basically that roll of tape. Now we have our big cylinder, so we have our large cylinder. It has a radius Okay, here's our axis point, right? Our rotation, our center of axis. So it has a radius of 5 and a height of 3. And then our small cylinder has a radius of 2 and a height of 3 because it goes all the way through. So we can find the volume of the large one, pi r squared times h. And then we have the volume of the small one, pi r squared times h. So we have 75 pi, and for 12 pi, and we would subtract because it's got a hole in the middle. So we end up with a volume of 63 pi units cubed. Okay, so let's look at this last one. Find the volume of the figure created when we have a point at 3, 0, 1, 3, and 5, 3. Okay, so this is that last shape that one of the last ones that we rotated. We're going to rotate it around the x-axis. So if you can imagine, let's flip this over. Get our reflection, our reflected triangle down here. And so we're going to end up with 2 cones. So the easiest thing to do would be to find the volume of each of those cones and find the volume of the cylinder and subtract your 2 cones. So the volume of your cylinder has a radius of 3 and a height, goes from here to here, so it has a height of 4. And your cones have a radius of 3, and each of them has a height of 2. So we find the volume of our cylinder, pi r squared h, which was 4. So that's 36 pi. And then our cones would be pi r squared h, and that would be divided by 3. So that's 9 times 2, which is 18, divided by 3. So that's 6 pi. There are 2 of them on either side, so it's 12 pi. So 36 minus 12, and you get 24 pi because it has 2 cone-shaped holes, one on either side. Okay, so when you rotate it, you have to pay attention to which axis you're going to rotate it around to decide what's going to be your height and what is going to be your radius. And then from there, you can do your calculations just like you've learned using the formulas that we know.